Lesson 106, we have already done quite a bit of it. It's talking about conic sections and how to tell which one is which just from looking at the equation. And we have already translated or shifted circles, parabolas, and ellipses. The book just does the ellipses today. We went ahead and did it early since it was almost the end of the year and I wanted you to have some practice with that. Today we are going to add in shifting the hyperbola, and that's actually the only one I'll do an example of. So first thing, I want everybody to look at these four equations and decide without doing any work to them which one is a parabola, which one's a circle, which one's an ellipse, and which one is a hyperbola, and being prepared to tell me how you know which one is which. So take a moment to take a look at those. Anybody want to volunteer to try to tell me one of them? Is there one of them that you can look at and tell which one's which? Luca?
The bottom one is a hyperbola.
Why do you think the bottom one is a hyperbola?
Or actually, it's thinking because there's x squared and then plus y squared.
Well, I've also got x squares and y squares in the first and the second one. What are we thinking there? Levi, what do you think?
Is the first one hyperbola because it's subtracting y squared?
Okay, the first one is a hyperbola. And the reason is because the coefficient, if I call this a in front of the x squared and this b in front of the y squared, they are one positive and one negative. Which means they're clearly not equal to each other, but one has to be positive and one has to be negative. So yes, that one is indeed a hyperbola. Somebody want to help with one of the other ones? Ming. How do you know the third one is a parabola? So there's no y squared, or another way of saying that would be b if b's the number in front of y squared is 0. Okay, what about the other two? That leaves circle and ellipse. Which one do you think is going to be which on that, Ryan?
So last one, a circle.
Why?
X squared and y squared, their coefficients are equal.
So this one is a circle because the x and the y coefficients are equal to each other, which means this one must be an ellipse, which means that we have A and B are not equal to each other, but they have the same sign, both positive or both negative. And I'll put the full list up on that as the last slide to make sure you have copied down on that. But just being able to take a quick look and tell what we have going on. So a little bit of review. We already know for ellipses that they have the same sign for the x and the y coefficient, so we can get that to where we have the x1 plus the y1 equals 1, not equals 0 over there. The center is the opposites of whatever's in the numerators. So if it's just x squared over and y squared over, that's the same as x minus 0 squared plus y minus 0 squared. So the center is 0, 0. But if the numerators are not just x squared and y squared, it's been shifted and we take the opposites on those. We also know that whichever one has the big denominator, that tells us whether it is horizontal or it is vertical. So if it is horizontal, how many vertices does any ellipse have, horizontal or vertical? I'm seeing fingers being held up correctly for 4 vertices. And we take our center HK and we take the square root of the denominators. So we'd add a and subtract a to figure out how far we go each way there, since a is the big denominator when I drew it vertically, or drew it horizontally. And then we go plus b and minus b to get to those four vertices. The foci are always on the major axis. And inside the ellipse. And if we want to get how far it is from the center to those, we take the big denominator minus the small denominator. They're already squared. We take those square roots to know how far we went to the vertices. But we take the whole denominator, squared and everything, and subtract them, and that's our focal distance squared. So then we just have to take the square root of that to get the distance that we go to those. Does that make sense? That also means if we want the small denominator, that would be the big D minus f squared. If we want the big denominator, that would be f squared plus the small denominator, just isolating whichever one of those three we're looking for. Thumbs up, thumbs down, are we good with that? All right, with a hyperbola, we know that if it is centered at 0, 0, it is just x squared over a denominator minus y squared over a denominator equals 1, or y squared can be the positive 1 and x squared can be the negative 1. If the numerators are not just x squared and y squared, it has been shifted, just like with circles and with ellipses. We take the opposites of whatever is inside those parentheses to get the new center. If the x's are the positive ones, it opens in the x direction. If the y's are the positive one, it opens up and down. So for this one, we have one that is going like that, and one that goes like this. How many vertices does a hyperbola have? Hold up fingers. How many vertices? It only has 2 vertices. These points that look like the vertices of parabolas, except that hyperbolas are shaped slightly different curvature than parabolas. Those other 2 may be guiding points for drawing our guiding box and our guiding asymptotes, but they are not vertices. So if it asks for vertices of a hyperbola, you only list 2, and you list both coordinates on them. We're not going to really work with it, but you will with Miss Cannon a lot. For a hyperbola, your f squared is not big D minus small d, but big D plus small d. And your foci for a hyperbola will also be inside. They'd be something like this on each of those. So we're just going to work on the basic way of going from the general form to the standard form so that we can graph a hyperbola. So let's give it a try on our one example. So, general form of that, do you agree from what we just said that it needs to be a hyperbola? For x squared and y squared, one's positive and one's negative. So we think it's a hyperbola. Can you tell me right now, well maybe not right now because it would depend on what you got over on the other side. So let's go ahead and get that into standard form so we can figure out what the new center is. To do that, I need to group my x's together, and I need a parentheses that starts with positive 1x squared, which means I have to factor a minus 1 out to get that to start with positive 1x squared. If I factor a minus 1 out from that, I need to factor a minus 1 out from the minus 2x, so I have plus 2x, and then I'm going to leave my space. I'm going to do the same thing for my y's. And I want my y's to start with a 1y squared, which means I have to factor out a plus 4. If I factor a plus 4 out of the 4y squared, I factor a plus 4 out of the 16y, and I have plus 4y, and I equal a space. Or I leave a space. And then I put the numbers on the other side, so equals 21. Everybody okay so far? Now I need to complete both of those squares. So -1, I need this to be x and something squared. And let's see, what do I put in that small parentheses that I just wrote? Plus or minus? Because it's always the same. And then what do I put out here in the space that I left? So everybody good with x plus 1 times x plus 1 is x squared plus 2x plus 1. Is that really a plus 1? What is it really, Liam? It's really a minus 1, so now I need to subtract 1 on the other side. If I really subtracted 1 on the left, I subtract 1 on the right. Okay, for my other parentheses, I keep my plus 4. I need a little parentheses that starts with y so that I can complete that square on it. Isaac, can you tell me what I need to put in this little parentheses that I just wrote? Plus or minus? Plus, again, it always is the same as whatever we have right here. And then what does that mean I need inside my long parentheses? Plus or minus? So I need a plus 4. Y plus 2 times y plus 2 is y squared plus 4y plus 4. Is it really a plus 4, Jamin? Is that one really a plus 4 that I just did to that equation?
No, it'd be plus 16.
It's really a plus 16, so I really need a plus 16 over here on the right. Which means that my right side is really 20 plus 16, 36, that's nice. Now, I have minus something with the x that's squared, plus something with the y that's squared, equals 36. That hyperbola equations need to equal what on the right side, everybody? 1. So I need to go through and divide all of that. Divide the right by 36, divide this by 36, divide this by 36. And I'm going to put my positive one first, just because I kind of like it that way. And so 4 over 36 reduces to 1 over 9, so that's y plus 2 squared over 9, because 4 over 36 is 1/9. And then I have my minus x plus 1 squared over 36 equals 1. So Matthias, what is my center going to be now for this hyperbola?
-2, 1.
You're close.
Oh, wait a second. Wouldn't it be -1?
Got to make sure that we get the x one first and then the y one. Does that make sense to everybody? So our new center is going to be -1, -2. So right here. Will this one open up and down or left and right? Everybody point in the air. That includes you at home. Which way is this one going to open? I don't see people at home pointing, giving me a direction yet. Okay, so it looks like we're saying it is going to open up and down. The y is positive, so it's going to open in the y direction. So to get to my vertices, how far from the center do I need to go in the y direction? Who can tell me that? Ben. So I take the square root of the y denominator. That's how far I go in the y direction. So 1, 2, 3. This is a vertex. 1, 2, 3. This is a vertex. If this one right here was -1, -2, I can see by looking at that my vertices still have -1 as their x-coordinate. That's still how far I went, left and right. But if I started at -2 and went up 3, I got to -1, 1. And if I started at -2 and went down 3, I ended at -5. Now to get my guiding box and my guiding asymptotes. Sydney, how far do I need to go in the x direction? The ladder. So square root of the x denominator is 6. So from the center, not from 0, 0, I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and just some kind of a guiding dot or dash on those. That lets me draw my box here. And then I can put in my guiding asymptotes that go through the center of the hyperbola and the corners of the box. Those are all dotted or dashed because they are not what I've really been asked to graph. All I was really asked to graph was the hyperbola. So I'm going to draw the hyperbola, and now it goes through the 2 vertices, and it gets infinitely close to the 2 asymptotes. It does not bend back away and start to curve inward on itself. I'm going to slightly move this one so I get a little better guiding here. And then I'll draw the other branch. Okay, let's get the equations of the asymptotes. The equations of those green lines. Whenever you write an equation of a line, what 2 things do you need? Going back at least to Algebra 1, what are the 2 things you need if you want to write down the equation of a line? That's one.
Slope and intercept.
So slope and a point could be the y-intercept. And so I'm going to give you 2 ways that you can figure out what that equation would be. First, if you look at those 2 green lines, do they have the intercept 0, 0 like we did before? For these 2, I can figure out the slope, but here's one intercept and here's another intercept. They're not the same, and they don't even look nice. They're not right on the corners of one of my grid boxes, so they're not going to be integers. So it's not super easy to get, but it isn't hard. Let's get the slope first because that's easy. Who can give me the slope for the line that goes upward? Somebody who hasn't answered yet. Somebody that I haven't called on yet. How do I get the slope of these lines? Micah, how do I get the slope of my green line, of my dotted green asymptote?
And you do rise with the run.
So help me with that.
It's 6 for, 3 over 6 or something.
So our slope for the positive one is a half, and for the negative one, it's negative a half. So that part's not hard. So one thing that we can do, if you want to do it with your y equals mx plus b, you put in the 1 line at a time because they have different intercepts. For the positive one, 1/2 x plus b. The one point that we know is on those 2 green lines is the center. We don't know the y-intercept yet. So we're going to put in, what was it, -1 for the x and -2 for the y. And get that b has to be -2 plus a half, so -1.5. So y equals 1/2 x minus 1.5. I should have been more consistent with just using fractions or just using decimals, but the point is to get the idea of how you can find that. For the other one, y equals -1/2 x plus b. Still the only point we know on the downward sloping line is -1 and -2. So now if we have -2, did I do that backwards there? That was -2 plus a half. This one is -2 minus another half, so -2.5. So -5/2 for b, which means that that equation is 1/2 x minus 5/2. And does that make sense? Your one that goes up has a higher intercept, negative 1.5. The one that goes down has a lower intercept, negative 2.5. Okay, the other thing that you may find easier, and we will wrap up with this for today, there is also the point slope form of the equation, which is y minus the y that you know is the slope times x minus the x that you know. So we could do our 1/2 x minus, what was it again, -1, and y minus the -2, so that we'd have y plus 2 is 1/2 x plus 1. And then if we did it with the negative slope, we'd have that. If we distribute it through, we'd get back to the same two equations that we had. The two choices of how to get there. Y equals mx plus b, plug in for x and y and get b. Or y minus the y you know equals m times x minus the x that you know, and you don't need to get b, you just need to do your distributing and simplifying. Questions on that? And you guys all remember the same process that we did up here with completing squares, if it's a parabola, or if it's a circle, or if it's an ellipse. We've done plenty of those problems. All right, I'm going to get ready for the test here in class, but if anybody wants to copy down this whole list of what we are looking for to tell which conic section is which, this is what we talked about on the first slide, and I'll leave that up for you to copy down as I start to hand out the tests. We will not do any equations this year that have an x times y term in there. So for all of ours, that c will be 0. But we look at the x squares and the y squares, and depending on what we see there tells us whether which one of those shapes that we have.